Cool. Let's start this talk about now. So this talk says it's about WebAssembly and an introduction guide, and I think in the notes for the schedule I said it's about audio. It is about all those things, but mostly this talk is about a problem I have, which is every time I go to a conference like this, I get inspired to start a new dumb side project. And this talk, or this side project, was entertaining enough for me that I made a talk about it. And so my hope for you all is that you all go away and you'll find a dumb side project and you go and give it a shot, regardless of how well it does or doesn't work. So the first half of this talk is inspired by a talk I saw by Katie Bell at Everything Open in Australia earlier this year. It said WebAssembly. I remember what assembly was. I've written it before. That sounded interesting, so I wondered what WebAssembly was. So I went to this talk and I found out. I am by no means an expert on WebAssembly. I'm an expert on doing dumb things with old things. So I'm going to teach you how to do dumb things with old things with WebAssembly. Don't expect details and details and details on WebAssembly. This is the labs conference, so I'll give you details and details and details on other things, just not WebAssembly. But we're going to use it as our platform. So as our agenda, we're going to have a quick introduction to WebAssembly. Then we're going to go back to the 80s and have a quick introduction to music production software of the 80s.
90s.
Then I'm calling 89 the 80s, but yes, 90s more than as much as 80s. And then we're going to try and merge the two things together and hope for the best. So WebAssembly, also known as WASM, what is it? What do we do with it? So I grew up in a certain generation of the internet where Flash was a new fancy thing. You could go to the Darude website and you could listen to their music from your web browser in school, and that was kind of cool and kind of fun. And Flash was starting to do all these cool things, but it had a lot of issues, and so it had to go away. At the same time, people liked using the internet to watch videos of cats. So we needed a way to make video players and media players, and so the general solution to this problem was turned out to become WebAssembly, which most importantly is an open standard that all the browsers implement, anyone can use. It provides us with a sandbox environment. We're kind of making flat packs for running inside your web browser. It uses the same security policies as your browser window, all those things. And it gives us some limited access to JavaScript for doing things like uploading and downloading files and a few other things like that. But as with all good assembly, I have written assembly. I'm sure many people in this room have written assembly, but the first rule of assembly is if you can do it in a different language rather than assembly, you use a different language. So today we're going to talk mostly about Inscripton, which is an LLVM-based compiler toolchain, and rather than outputting binaries for your operating system, it takes your C++ source code or your C source code and outputs it to WebAssembly. It can also do some other fun, funky things, like it can convert OpenGL calls to WebGL. It implements some useful libraries, such as the SDL2. It implements pthreads badly, many parts of POSIX. I personally like C++ because I'm a user interface designer and a user interface programmer originally, and user interfaces are made up of objects, and so I need a language with objects that's not Python because it causes too many headaches. Today I'm talking about Inscripton for doing C++ with WebAssembly. There is Rust tools for WebAssembly. There's Go tools for WebAssembly. I'm sure there's Python tools for WebAssembly. If you have a different language you like, go and find its toolchain in its way of doing WebAssembly. And so what Inscripton is going to do for us is it's going to provide us a bunch of shell scripts to set up a common compiler environment variables, and it provides us with some wrappers for make, CMake, configure, as well as providing standard compilers that you'd expect with Clang or GCC. or so forth. So theoretically, as I was told when I started my project, it shouldn't be that hard to take an SDL2 app and make it run in WebAssembly instead of natively. And so that is what my afternoon side project was. But to talk about my afternoon side project, we're going to talk about trackers. Trackers are the audio software of the 90s. They came about in the late 80s with Amigas, introduced 16-bit samplers. All of a sudden, you could do audio production on your computer. People wanted this also for not just making audio, but there was the demo scene. This is how they did their audio. This is also how a lot of games did their music. And it was also influential in jungle music. Now, one of the things that surprised me, I forgot to tell you, AV guys, we might have some laptop audio, if that works. We've tempted the demo gods a lot already, but one of the things that surprised me is we still have tracker software in Tumbleweed. And so this is Hively Tracker. It did not like being made full screen, so we're not going to do that. I went on the internet, as one does. I downloaded a thing. I set my audio to that. And press play song. I'm guessing we're going to hear nothing. Oh no, there we are. There is some audio coming from somewhere. And so we can see with our tracker here, we have a bunch of different tracks playing notes. And this is how you did early, audio production in the early 90s. But where the project I'm interested in comes into it is, say you don't want to make audio music at home on your big computer. You want to make music while you're out and going. So, of course, at the time, the only portable device that we had access to, here is our slide on our demo. There's a couple of other open source trackers that are still around that you can use. But people wanted to make sound as they were going. I couldn't find any CC licensed images, but someone came up with Little LSDJ, which was a way to run a tracker on a Game Boy because you wanted to make music while you were going. And inspired by that, someone created Little Piggy Tracker, which was designed to run on newer devices. I have one here. Another project I've done in the last year was porting Little Piggy Tracker to this device, which is good fun. But again, I hope I can, if I come to the right place here, this terminal is broken. I'm using muscle memory and I'm getting the wrong terminal. That's a future Simon problem. Don't ask me why we're running this in GDB, but this is development software. It seems it runs in GDB. I have a Super Nintendo controller here, which was not plugged in. And so now we're going to exit and do this process again. As I said, this was all prepared before the screen didn't work. So we don't need the debugging symbols. So I have my Super Nintendo controller. Last Hack Week, I made a video of trains because that was the theme for Hack Week. Behind the video of the trains was this little track that I made, and I can show you kind of how this tracker works. So the reason I like trackers is with a controller like this and a bit of muscle memory, you can move through things quite quickly. So I can hold the right trigger here and I can go between screens. So this track here is a sample that's been sliced up, and each note is a different part of the sample. Then we group that into our notes we have into chains, and we can have a bunch of different instruments. Now, I can have in this, I can have 8 different channels of audio playing. Each channel can only play one thing at the same time, but it can play different instruments. But here we kind of have, I think that's the bass line. So if we come in here and see we're playing a note, we're playing some other notes. And this is LGPT. I had lots of fun porting it from SDL1 to SDL2. So I would run on this device that I'll talk about briefly at the end. But this is what I thought, wouldn't it be cool if you could run this audio software inside a browser for no other reason than you can? And so my aim was to port LGPT to the web browser because everyone has ported it everywhere else already. And so, now we're just going to take a quick break because the reason I actually found out about LGPT is thanks to this device. This is called a Pico Tracker. I saw a conference talk on this where we actually built this a couple of years ago. It is an open hardware tracker. Costs about $50 if you want to get the parts yourself and 3D print it. They do some kits. They're going to sell one soon as well. It uses a Raspberry Pi Pico to run similar software to what we just saw. And it has a couple of cool inbuilt synths and lots of fun things. And so I was introduced to that, which led me to LGP. I like this hardware better because it's got buttons on the back, but Pico Tracker is fun as well. So in the conference talks that inspired me, this is one of them. But now let's get to doing our porting. So the first thing we want to do is we want to compile it. Now, LGPT just uses straight make files. It doesn't use a makefile generator. And that works well enough and hasn't annoyed me to the point where I've decided to swap to using a makefile generator. So that was the wrong button. All we had to do was use EMCC and EM++ as our compilers. We say we're going to use the SDL2 port. We want to use pthreads. And then the other important thing at the end is we want EM_run. And then we can compile this application just as if it was any other thing. I'm not going to show you me pressing make and making it work, compile, because it's probably not important. But beyond that, there is a couple of things we need to change to run our application in web browser. The main thing is with SDL apps, most other GUI apps I've ever encountered, normally you have an event loop that sits in a infinite loop and just waits for events to come in and deals with them. Web browsers get really grumpy if you block them forever. So we're not allowed to do that. And so what we do is we remove the loop part of our main loop. We turn it into a function that comes through, processes any events in the queue, and then exits. And so we need to use this function here to tell Inscripton what our main loop function is, rather than calling it directly and looping in it forever. Similarly, we need to poll for events rather than sitting in our loop waiting for events. And fundamentally, that is the only bit of code that I had to change to work on this. But the other thing we want to do is, as I was saying before, WebAssembly runs with a sandbox. And so we want to put our config files up onto the platform. And so we use this preload file syntax here to do that. We use EM_run. That's going to helps us set up a default basic debugging environment. And so now let's have a look at LGPT running in a web browser, because again, I bled the wrong terminal, but I spent an afternoon of a conference working on this, and this is where I kind of got to. So I can just type make, gonna compile or not compile anymore. I need to just load our environment. So I've got all the tools in my path, and then I should be able to, hopefully I didn't kill it. But if we now run this guy, you can see we have our tracker. It's complaining because it can't. It can't find the SNES controller, which is unfortunate. But we have a tracker here, and it is running in my browser. I can create a new project. This, unfortunately, is where it starts to fall apart, because LGPT is very opinionated about the audio sample format it wants. WebAssembly is also very opinionated about the format it wants. They are not the same format. I can make audio play not properly. If we try and load a sample, it's trying to play audio, and at this point, I'm not sure if that is because the audio is running in a P thread and the browser doesn't like the thread well, or if the format is not quite lining up. I spent 3/4 of a day messing with this, and then I decided that it's probably not worth spending my time on, because this was a fun project to learn things. I had fun and I had learned things, and so I decided to park it there. But that did leave me with a bit of a problem for this talk, in that I had to do a cool demo of something. And so we're going to take a little pivot now. I was going to try and hide this, but I don't think I can anymore. So originally, there was a 2D space shooter called Chromium that's been around for years. When the Chromium browser came out, we had to rename it to Chromium BSU. I thought it would be cool to run Chromium in Chromium. I didn't, however, feel like porting a bunch of OpenGL 1 to OpenGL 3 to make that work. So fortunately for me, there are people in the world that have other similar dumb ideas that I have. So we're going to fire up a web server here. And if I come to... It's fun thinking up port names when you have 5 web servers running on your computer. If we go to jazz.html, you can see here we have DOSBox. I made this bigger the other day when I had a mouse with a scroll wheel. Zoom. There we go. Here we have DOSBox. So DOSBox, someone already ported it to work with Inscript and run in a browser. It uses SDL too. Fun. I also ported DOSBox to work on this guy for fun. I need to do some key mapping, but so now we can. We have to mount. We're going to mount a C drive as the root file system. Gives us this error. In practice, we are running in a sandbox. There's not much in there, but now we should be able to run. And here we have Jazz Jackrabbit, which is the first game ever that I got on CD. In my opinion, of all games in the world, it probably has the best soundtrack. And so now we are running DOS games in our browser, which is questionable if it's useful. I guess it's easier to set this up for other people than yourself, but we can sit here and we can happily game in our browser, which was the keys are mapped wrong, but welcome to playing a DOS game in your browser. And I figured that was a good demo, but by this point, I was already heading down a rabbit hole. And I had headed down the rabbit hole of, as I was saying, early 90s music production. When Jazz Jackrabbit came out, I had the CD version, but it also came out on floppy disk. On a floppy disk, there isn't enough space to have all those big WAV files for each song looping through. So what they did is they shipped songs as tracker files, and they had an inbuilt tracker player in the game. And so now we're going to open up a different DOSBox image. And yes, we can run. And here we have Screen Tracker built for DOS. We're going to continue. And we're going to load a module. And let's see, somewhere, I'm not going to be able to use my mouse. In this directory here, someone has, the audio files for Jazz Jackrabbit didn't quite ship in screen format, but they shipped in something close to it. So someone has nicely converted it. And now we can take that cool menu music and when I remember the play button, we can play the music from the game in a tracker in DOS. And as I promised, here is audio production software running in your browser. And as you can see here, it's using multiple different instruments on one channel. I don't know how to use this software very well but we can go F1. You can see the chains that are playing. Again, we get a nice instrument view with all our notes. Here we can see the different samples that are playing. And so yeah, that was this was the beta demo. Here, if you want to run EM DOSBox, here is how you do it. They make it really easy to package DOS games. So when you find your old PDs with DOS games, you just dump them in and you can package them up and it'll run in the browser. And then you can share your DOS games with everyone. And we've come back to trackers already. And now I'm going to take a quick minute to talk about this piece of hardware, which is an RG35XX Plus, which is originally what I started porting to. Basically, it's an Orange Pi with really crappy security, which is not what you want from a security perspective, but from a reverse engineering perspective, the fact you can go to GitHub, you can download an application to give you SSH access, and it uses a basic root password. You can then enable Wi-Fi, SSH into this, compile your software on it. I think there's firmware being mainlined for it slowly. As far as I've worked out, it uses a custom SDL2 setup where as long as your application uses the SDL2, it'll come up as the main thing. It was written for RetroArch. I have had DOSBox on it because it's important to be able to play Jazz Jackrabbit on this as well, even if I need to plug in a USB keyboard. But the other thing I've done with this is I've got LGPT running on it. Thanks to the community in another project, they managed to compile all the audio kernel modules. And so I have USB MIDI support on this, and that makes audio production on this fun. I've written music for it on a plane. It's a good fun thing. If you want a single board Linux computer with graphics to mess with, I would kind of recommend one of these. It's good fun. And I think that is the end of my talk, and I forgot a question slide. So does anyone have any questions on the randomness of this talk that just was?
Why?
Because why not? Because why not, Steve? Why not? Because I can, and I learned something, and it was a fun way to spend enough. I like porting things to things, and porting applications that shouldn't run in the web to the web was a good bit of fun experience. I might even finish porting Hive Tracker, but that needed to convert from SDL1 to SDL2, and I didn't feel like doing that, or didn't have time to do that before the talk.
If I understand right, the encrypting thing turns the application into something that you can run in the browser, right?
Yes.
So does this have also SDL3?
I am not sure what the SDL3 port is like for encrypting.
Because it has the GPU also, the new SDL GPU API that you can use to program also the GPU in a more modern way. But I wonder, that would be cool because then you can, not write Vulkan and stuff like that.
Yes.
And still have the stuff in the browser. So
I'm not sure. I haven't got that far yet. As you can see from the tracker app I was running, porting it from SDL1 to SDL2 so that it would use the GPU memory instead of normal memory was probably a bit of overkill, but it needed to be done to run on that device. So I haven't done heavy 3D programming for a long
If you want
time.
to push it, you can try that.
I'm sure it is in their plans for the future, and how that maps into WebGL, I'm not sure,
Thanks.
but it would be interesting to see. Other questions?
So you're running on the RG35XX, you're running the stuff on the browser still?
No, on the RG35XX, I set up SSHFS, and because it's basically running Ubuntu, so I just installed the compiler and I compiled it on the device. I put a link to it down the bottom. I did go through and work out every library that was on there and went to the Ubuntu mirrors, and I created an SDK that you can download and use to compile, because we wanted to build the application in a GitHub action. So I can now use this and a GitHub action to build the LGPT software to run straight on here.
Cool. What about the Super Nintendo controller on the browser? No way to get that done?
I didn't spend more than 30 seconds trying or looking or caring,
Fair enough.
because at that point the audio wasn't working, and that was the more important thing. Any other questions? All right, well, thank you all much for listening. Enjoy lunch. Sorry for the delay.